So we classify chemical reactions, just like we classify all kinds of other things. We can classify them by looking at what happens, and that's what we've been talking about so far. A precipitation reaction. We mix some things, we see a solid form. That's a precipitation reaction. We can tell because of what happens. An acid-base reaction. The acid and the base neutralize each other. That's what happens. A gas evolution reaction. We see gas bubbles form or something comes out that has a smell. A gas is evolved. That's what happens. Now, many of these gas evolution reactions are also acid-base reactions. So some reactions fall into more than one category. And then we just talked about oxidation reduction reactions where we have electrons being transferred. A subcategory of those is combustion reactions. We can also classify chemical reactions by looking at what's happening with the atoms. So we look at the chemical equation for the reaction and see what's going on. And so these have different names. We can have a synthesis, which means we're making something, we're synthesizing it. Synthesis or combustion, two different names for the same thing. Sorry, that's not combustion. Combination. And the generic equation is one substance plus another substance yields a combination of the two things. Usually this is two elements, but it doesn't have to be. The hallmark of this is that you've got one product. The opposite of that is decomposition, where you're taking something apart. So one compound reacts and forms two different things. It's decomposing. Displacement, I'd like to talk about double displacement first. So we've talked a lot about reactions that are double displacement reactions. These are the precipitation reactions and the acid-base reactions. This is where we've got A and D and B and C swapping partners. Okay? This couple comes to the party, that couple comes to the party. They switch partners. The products are with the partners switched. Okay? Double displacement, because two people are displaced from their positions. The other one, displacement, or sometimes it's called single displacement, just to be extra clear. This is a little bit different. This is where A went to the party by himself. They used to call that going stag. I don't know if they still call it that or not. So A went to the party by himself. He didn't have a date. And B went with C. And in the mingling at the party, C decides that A is a much better catch, and so she goes home with him, and B goes home by himself. A single displacement. Okay? We'll learn in Chapter 17 how do you predict which guy's going to get the girl in the end. And then these slides just go over and sort of elaborate on this. So here's an example of a combination reaction. We've got sodium and chlorine reacting to form one thing. It's a combination reaction. Decomposition. Here's an example. We have one substance, water, and it's reacting to form two different things. One reactant, multiple products. Single displacement. Here we've got zinc and copper chloride. Zinc takes copper's place. He gets chlorine. So zinc and chlorine leave together, and now copper's by himself. One person has been displaced. Single displacement. And the double displacement, we've talked a lot about those, so the swapping of the partners. This kind of reaction may be a precipitation reaction. It might be an acid-base reaction. It might be a gas evolution reaction. And if you're trying to predict products and you're not sure what to do, this is the first one you should try. See if you can pull the reactants apart into individual ions and swap the partners and put them back together. That's the most common thing you'll need to do. This is looking at classifying them by what's going on with the individual atoms. Synthesis, decomposition, single displacement, double displacement. So let's apply that. Classify each of these. Now this is giving us specific choices. Okay? And that's what will happen on a test. It'll be multiple choice. Some of these, it may be a synthesis reaction and also a redox reaction. It can have two categories, but I'm going to give you one set of categories, and there will be one correct answer, okay? So if we look at this first one, is this a synthesis, decomposition, single displacement, or double displacement? Single displacement. Here's Al coming to the party by himself, and here's hydrogen and phosphate. Al is leaving with phosphate, and hydrogen's going home alone. That's a single displacement. We'll call that SD, single displacement. How about this one? Double displacement. Copper and sulfate, potassium and hydroxide, they're swapping partners. This is also a precipitation reaction, but that's not one of the choices. So this is a double displacement, DD. How about this one? Synthesis. Okay, because we're putting two things together to make one. So we'll call that S for synthesis. And how about this one? Decomposition. Okay, that's something that will be on the test on Monday. Okay. Any questions?
Wait, we have a test every Monday?
We have a test every Monday. Yep.